Hello, today we're going to be talking about nth roots and simplifying radicals. So our objectives for today are that students will be able to simplify radicals. Let's get started. Alright, so as a warm-up, what I want you to do is try to list out the perfect squares, cubes, and fourths. So off the top of your head or using your calculator, take a minute to try to jot down all the perfect squares you can think of, the perfect cubes, and perfect fourths. So pause your video now and do this, and when you come back, I'll have them written on your screen. Alright, so perfect squares we should be very familiar with, right? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, and so on and so on. So those should be the ones we're most familiar with. Perfect cubes we've worked with a little bit, so 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, or to the third power when we're talking about cubes, and so on. Perfect fourths we're probably not as familiar with, but this is saying 1 to the 4th power, 2 to the 4th power, 3 to the 4th power, 4 to the 4th power, and so on. So the little chart that I gave you guys today, what I want you to do is use that chart to help you become familiar with all of your perfect squares, perfect cubes, and perfect fourths. Because for this entire chapter, you need to be extremely familiar with all of these and even further. So that little chart, I want to make sure that you bring it with you to every class and use it to help you solve these problems, all right? Because you're going to need to be very familiar with your squares, cubes, and fourths. All right, you can also use your calculator for this to help you. But please, please, please become very familiar with these, and let's move on and see how they will be helpful. All right, so for this whole chapter, we're going to be talking about radicals. So I think it's very important that we understand all the different parts of a radical. The nth root of a real number, a, can be written as a radical expression, or n rad a. The little n on the outside, we refer to that as the index. Then the part that is our rad sign, we call that the radical sign, and you'll hear me say rad for short. Us mathematicians always simplifying things and shortening things. All right, so the rad sign or the radical sign. And then your a, or the number inside the house or inside the radical sign, we refer to that as the radicand. All right, that's the fancy math term for it. If there is no index, so if there's no n on the outside, we always assume that n equals 2, or that it's just a square root. It's not a cube root or a fourth root or a fifth root. All right, if there's no n on the outside, it's just a 2 or a square root. All right, so let's go through these examples and give all the possible roots to the radicals below. So first off, square root of 16 can be plus or minus 4. It could be negative 4 squared gives you 16, positive 4 squared gives you 16. Square root of 121 is also plus or minus, and it's 11. Square root of 289, if we were to plug that into a calculator, we would get a whole number. We would get 17, so it's plus or minus 17. Then if we have square root of 4 25ths, we can simplify this as square root of 4 over square root of 25. That gives us 2/5, and it's going to be plus or minus, because it could be positive 2/5 or negative 2/5. Then, if we have the cube root of 8, it's only positive 2, because negative 2 times negative 2 times negative 2 would give us negative 8, not positive 8. Cube root of 343 is just a positive 7, because it's the same thing. It has to be positive if it's a cube root. Then, cube root of negative 125, if you were to plug that into your calculator, you would get negative 5, because negative 5 times negative 5 times negative 5 gives us negative 125. If it was positive 5, it would give us positive 125. Then, cube root of negative 1 over 27, rewrite this as, that's a 3, cube root of negative 1 over cube root of 27. That's going to give us negative 1/3, because the cube root of -1 is -1. Cube root of 27 is 3. You can use that chart to help you here. The fourth root of 1 is going to give us positive or negative 1, plus or minus 1. Fourth root of 2,401, if you plug that into your calculator, should be plus or minus 7. Fourth root of 4,096 is going to be plus or minus 8. Fourth root of 81 over 16, rewrite that as fourth root of 81 over the fourth root of 16, and you're going to get 3 over 2, and it's still plus or minus. So just to summarize, if we look at all these examples, we can come up with certain rules. So if our index is even, if it's a square root over a fourth root, and the radicand is positive, so the number inside the house is positive, we know that we're going to have real roots, and the number of roots is going to be 2, and we always do plus or minus. Okay, that's why we have 2 roots. It's always plus or minus that of your root. If our index is odd, so if it's a third root or a fifth root, and the radicand is positive, we're going to have real roots, but we're only going to have 1 root, and it's going to be positive. If our index is odd, so if it's a third root or a fifth root, and the radicand is negative, we still have real roots, but we only have 1 negative root. And this one's starred because we don't see it very often. If we have an even radicand, all right? So this goes back to our complex numbers or imaginary numbers, because if we have an even radicand or a square root, and it has an even index and a negative radicand, so we're taking the square root of a negative number, the fourth root of a negative number, we end up with imaginary roots, right? Because we technically can't take the square root of a negative number. We end up with imaginary roots. And you're always going to have 2 plus or minus. So you're going to have 2 roots. It's always going to be plus or minus your root. All right, so this chart right here is very important to know. When we're taking or we're simplifying radicals, we always need to know what type of roots we have and how many roots to expect. All right, so now we're going to get some practice simplifying radicals. And an important thing to notice or to remember is that if a radical has more than 1 root, so if it's an even index, the radical sign indicates only the principal or positive root. So whenever we're simplifying radicals, we do not put a plus or minus sign, only when we're solving radicals. So in this case, simplifying radicals, we're just putting the positive or principal root. So what we want to do is break down 117. If we're taking the square root of 117, we want to list out all the factors of 117 until we find a perfect square. So 117, let's see, we've got 1 times 117. 2 doesn't go into it. 117 divided by 3, we get 3 times 39. None of those are perfect squares. 4, does 4 go into it? Nope. 5 doesn't go into it. 6, nope. 7, nope. 8, nope. 9, oh, yep, 9 times 13. And 9 is a perfect square. So these are our winners. These are the factors we want. So break down 117. We can say square root of 117 is the same thing as square root of 9 times the square root of 13. And we know that the square root of 9 is equal to 3. And then we just want to bring down rad 13. And that would be our final answer. So we can simplify the square root of 117, break it down, and our simplified radical is 3 rad 13. All right, now we want to simplify number 3, 2 times the third root of 48. So first thing we want to do is list out the factors of 48 until we get a perfect cube. We want to look for those perfect cubes, which is why we need to be so familiar with them, or use your chart. So 1 times 48. Neither of those are perfect cubes. 2 times 24. Nope, not perfect cubes. Let's see, 3 times, that would be 48 divided by 3. 3 times 16. 16 is a perfect square, but not a perfect cube, so we got to keep going. 4 times 12. Perfect square, we got number 4. 4 is a perfect square, but neither of those are perfect cubes. 5 doesn't go into it. How about 6? 6 times 8. 8 is a perfect cube. 2 cubed gives us 8. So there's our winners. Those are the factors we want. So we want to break down the cube root of 48 to be the cube root of 8 times the cube root of 6. And don't forget to bring down this 2 as well. We can't forget about the 2. Then we can take the cube root of 8, gives us 2. So bring down this 2 as well. 2 times 2 times the cube root of 6. 2 times 2 gives us 4. Bring down cube root of 6. And that is our simplified radical. And we're done. All right, number 5, we've got the cube root of negative 250. And we know that if it's a cube root, if it's an odd index, we can take the negative cube root of an odd index. So this is possible. We're not going to end up with imaginary roots. We're going to end up with a real root. All right, so first thing we want to do is find all the factors of 250 until we get one that's a perfect cube. So we can break down 250. So 1 times 250, not perfect cubes. 2 times 125. Oh, 125 is a perfect cube. 5 cubed gives us 125. So let's break this down. Break it down to the cube root of negative 125 times the cube root of 2. All right, and we always want to put the negative with the number we're going to take the cube root of so we can get rid of that negative inside. So the cube root of negative 125 gives us negative 5. And then bring down cube root of 2. And that is our simplified radical. All right, number 7. What I want you to do is pause your video and try to do number 7 on your own. See if you can break down 162, find a perfect fourth, all right? Find a number that is something to the 4th power, all right, is a factor of 162. Simplify this radical. When you come back, I'll have the answer written on the board and we'll go through it. All right, so for number 7, first thing we wanted to do was look for factors of 162 that are perfect fourths. So start by listing out all your factors of 162. 1 times 162, neither are perfect fourths. 2 times 81. 81 is a perfect fourth. 3 to the 4th power gives you 81. So break this down to the 4th root of 81 times the 4th root of 2. Because whatever's what's inside the house, so our radicand times our radicand is equal to whatever's in our whatever our original radicand is. Okay, so then 3, bring down the 3. 4th root of 81 gives us 3. Bring down the 4th root of 2. So 9. 3 times 3 gives us 9 times the 4th root of 2. This is our simplified radical and our final answer. All right, now when we're dealing with radicals with variables, in order to simplify them, there's a couple things we need to remember. If it's square roots, the exponents must be multiples of, let me get my pen. Square roots, exponents must be multiples of 2. Cube roots, the exponents must be multiples of 3. And 4th roots, the exponents must be multiples of, you guessed it, 4. All right, so let's see a couple examples of how we do this. All right, so if we want to take the square root of 32, x to the 4th, y to the 9th. First things first, we know that 16 times 2 gives us 32. So we want to break this down to 16 times 2 because we can take the square root of 16. So we're breaking this down, square root of 16 times square root of 2. Now we want to break apart our exponents, But in order to take the square root of x to the fourth, or of our x's, what we're taking the square root of has to be, our exponent has to be a multiple of 2. So x to the fourth, 4 is a multiple of 2. So let's write it under our radical sign that we're going to take the square root of. Y to the ninth, 9 is not a multiple of 2, but 8 is. So we write y to the 8th over here, and we'll have one y left over, so we put it on the side that we're not going to be taking the square root of. That gives us 9 y's, or y to the 9th. Then, this is our side we're going to be taking the square root of. So the square root of 16 gives us 4. X to the fourth, if we take the square root of that, we have, what we're saying here is x to the fourth, and we're taking the square root of that. So we're taking x to the fourth, we're doing 4 divided by 2. So we're left with x squared on the outside. Then y to the 8th, if we're taking the square root of it, we do 8 divided by 2. We're left with y to the 4th. Then we just bring this down because we can't do anything with it. So times 2y. And this is our simplified radical, and we're done.
All right, here's another example. So we're taking the cube root of 216, n to the third, n to the sixth. So what we want to do is first take the cube root of 216. We know that's 6, all right, because 6 to the third power gives us 216. So we can take the square root, or the cube root of 216, and then we can take the cube root of n to the third and times the cube root of n to the sixth. So we want to break this down into 3 separate parts. All right, another way of doing it. So we know this is 6, then m to the third root of something cubed, they just cancel out. So we're left with 1m. And then over here, if we were to take the cube root of n6, we would do 6 divided by 3, so we're left with n squared. And that would be our final answer.
All right, number 13. Now here, we know the cube root of 64 is 4. So what we want to do is we want to break this down into what we can take the cube root of and what we can't take the cube root of. So we can take the cube root of negative 64, be negative 4. Now we've got x to the 10th. 10 is not a multiple of 3, but 9 is. So let's say x to the 9th, and we've got 1x left over. So we can't take the square root of that, or the cube root of that. Then y to the 21 power, or the 21 degree, right? 21 is a multiple of 3, right? 21 divided by 3 gives us 7. So let's put that on the side we can take the cube root of. All right, now that's everything. We've broken it down. So let's take the cube root of this side. Cube root of negative 64 gives us negative 4. X to the 9th, if we do 9 divided by 3, we get x to the 3rd. Y to the 21st power, 21 divided by 3 gives us 7. Y to the 7th. And then this is what we can't take the cube root of, so we just rewrite it below, and it's as simple as it gets. This is our simplified radical, and we're done. All right, number 15. 4th root of w to the 4th, v to the 17th. So we're going to break this down into what we can take the 4th root of times what we can't take the 4th root of. So w to the 4th, 4 is a multiple of 4, so we can take the 4th root of that. V to the 17th power, 17 is not a multiple of 4, but 16 is. So we want to write v to the 16th on the side we can take the 4th root of, and we have 1v left over, so we'll write it on the side we can't take the 4th root of. Then, take the 4th root of what you can take the 4th root of. So, 4th root of w to the 4th gives us a single w, because 4 divided by 4 gives you 1. Then v to the 16th, 16 divided by 4 gives you 4. So we're left with v to the 4th. And then copy down what you can't take the 4th root of. All right, because we can't simplify it any further. And that is our final answer. All right, last but not least, number 17. Let's break this down into what we can take the fourth root of and what we can't take the fourth root of. So this is what we can take the fourth root of times what we can't. So 625, we know the fourth root of that is 5, so we can take the fourth root of 625. C to the 23rd. 23 is not a multiple of 4, but 20 is. That's as close as we can get to 23 and still be a multiple of 4. So let's say C to the 20th, and we have 3 C's left over, so we'll put them on the other side. Then we've got D to the 11th. 11 is not a multiple of 4, but 8 is as close as we can get, so let's put D to the 8th over here, and we've got 3 D's left over, so we'll put them over there. Then take the fourth root of what you can take the fourth root of. So fourth root of 625 gives us 5. C to the 20th, 20 divided by 4 gives us 5. D to the 8th, 8 divided by 4 gives us 2. And then bring down what you can't simplify any further. So the fourth root of C to the 3rd, D to the 3rd, and there's your simplified radical, and you are done. Alright, so I hope you learned a thing or two about nth roots and simplifying radicals today. So please look to your teacher or look to the board to see what to do next, and I hope that you have a great day.